main panel is a crucial component of a home's electrical system, and failing to inspect it can lead to missed potential electrical hazards. These hazards can include overloaded circuits, faulty wiring, improper grounding, and damaged or malfunctioning circuit breakers. Electrical hazards can pose significant risks to the occupants of a house, including fires, electrical shocks, electrocution, and damage to appliances and electronics. An incomplete inspection of the main panel compromises the overall safety assessment of the home. This could leave homeowners unaware of potential electrical dangers. Potential buyers may hesitate to purchase a house if the main panel hasn't been inspected, indicating a lack of due diligence or potential safety concerns. Insurance companies may charge higher premiums for homes with incomplete safety inspections, including those that don't include the main panel. The inspector could be held liable for damages or injuries resulting from missed electrical hazards due to an incomplete inspection. Recommended actions to take if the main panel was not inspected are as follows. Firstly, contact the inspector and request a follow-up inspection specifically to examine the main panel. Secondly, if the inspector doesn't agree to inspect the main panel, consider hiring a qualified electrician to perform an independent inspection. If you're selling the house, disclose that the main panel wasn't inspected during the initial safety inspection. This allows potential buyers to make an informed decision. Overloaded circuits occur when too much current flows through a circuit, exceeding its capacity. This can cause wires to overheat and potentially start a fire. Faulty wiring, which includes damaged, frayed, or improperly connected wires, can also lead to electrical fires and shocks. Improper grounding can result in electrical shocks if there's a fault in the system. Grounding provides a path for stray current to safely return to the source. Damaged or malfunctioning circuit breakers may fail to trip when there's an overload or short circuit, increasing the risk of fire or electrical damage. Electrical fires can spread quickly and cause significant property damage and injury. Electrical shocks can range from mild tingling to severe burns and cardiac arrest. Electrocution is a fatal electrical shock. Damage to appliances and electronics can occur due to power surges or electrical faults. To elaborate on the importance of each electrical component and safety measure, consider the following. Firstly, circuit breakers. Circuit breakers are designed to protect electrical circuits from damage caused by overcurrent or short circuits. They automatically interrupt the flow of electricity when a fault is detected, preventing overheating and fires. Regular inspection and testing of circuit breakers ensure they are functioning properly. Secondly, grounding. Grounding provides a safe path for electrical current to flow in the event of a fault. It helps to prevent electrical shocks and electrocution by directing stray current to the ground. Proper grounding is essential for all electrical systems and equipment. Thirdly, wiring. Wiring is the backbone of any electrical system, and it must be properly installed and maintained to ensure safety and reliability. Damaged or deteriorated wiring can create a fire hazard or cause electrical shocks. Regular inspection of wiring is essential to identify and correct any problems. Fourthly, outlets and switches. Outlets and switches are the points of contact for electrical devices and appliances. They must be properly installed and grounded to prevent electrical shocks. Damaged or loose outlets and switches should be replaced immediately. Fifthly, electrical panels. Electrical panels are the central distribution points for electricity in a building. They contain circuit breakers or fuses that protect individual circuits from overcurrent. Electrical panels should be inspected regularly to ensure that all components are in good working order. Sixthly, GFCI ground fault circuit interrupter protection. GFCI protection is designed to prevent electrical shocks by detecting ground faults. GFCIs are commonly used in bathrooms, kitchens, and outdoor areas where there is a risk of water exposure. Seventhly, arc fault circuit interrupters or ASIs. ASIs are designed to protect against fires caused by arc faults, which are dangerous electrical conditions that can occur in damaged or worn wiring. ASIs are now required in many new homes to provide an additional layer of fire protection. Eighthly, surge protection. Surge protection devices protect electronic equipment from damage caused by power surges. Power surges can occur due to lightning strikes, utility switching, or other electrical disturbances. Surge protectors should be installed on all sensitive electronic equipment. Ninthly, smoke detectors. Smoke detectors are essential safety devices that provide early warning of a fire. They should be installed on every level of a home and tested regularly to ensure they are functioning properly. Tenthly, carbon monoxide detectors. Carbon monoxide detectors are designed to detect the presence of carbon monoxide, a colorless, odorless gas that can be deadly. They should be installed near sleeping areas and tested regularly. 11thly, proper use of extension cords. Extension cords should be used temporarily and should not be overloaded. They should be inspected regularly for damage and replaced if necessary. 12thly, avoiding water contact with electricity. Water is a good conductor of electricity, so it is important to avoid contact with water when working with electrical devices or appliances. Never use electrical appliances near water and always dry your hands before touching electrical equipment. 13thly, qualified electrician. Electrical work should only be performed by a qualified electrician. Electricians have the training and experience to safely install, repair, and maintain electrical systems. Attempting to do electrical work yourself can be dangerous and may violate building codes. 14thly, regular inspections. Regular electrical inspections can help to identify potential problems before they become serious hazards. Inspections should be performed by a qualified electrician and should include a thorough examination of all electrical components. 15thly, compliance with electrical codes. Electrical codes are designed to ensure the safety of electrical systems. All electrical work should be performed in compliance with applicable codes. Building codes can vary from city to city or jurisdiction to jurisdiction. These codes must be adhered to. 16thly, proper labeling of circuits. Proper labeling of circuits in the electrical panel makes it easier to identify and shut off power to specific areas of the home during maintenance or emergencies. 17thly, avoiding the use of aluminum wiring. Aluminum wiring was used in some homes in the past, but it is now known to be a fire hazard. If you have aluminum wiring in your home, it should be inspected by a qualified electrician. 18thly, maintaining clear access to the electrical panel. The electrical panel should be easily accessible in case of an emergency. Do not block the panel with furniture or other objects. 19thly, using the correct type of light bulbs. Use the correct type of light bulbs for each fixture to avoid overheating and fire hazards. Do not use bulbs with a higher wattage than the fixture is designed for. 20thly, preventing pest infestations. Pests can damage electrical wiring and create a fire hazard. Take steps to prevent pest infestations in your home. 21st, understanding your home's electrical system. Familiarize yourself with your home's electrical system, including the location of the electrical panel, circuit breakers, and main shut-off switch. This knowledge can be helpful in case of an emergency. 22nd, knowing when to call a professional. If you have any concerns about your home's electrical system, don't hesitate to call a qualified electrician. It is always better to be safe than sorry when it comes to electricity. Here are some examples of situations that warrant a call to a professional. Firstly, flickering lights. Flickering lights can be a sign of a loose connection or other electrical problem. Secondly, burning smells. Burning smells coming from outlets or appliances can indicate overheating or a fire hazard. Thirdly, frequently tripping circuit breakers. Frequently tripping circuit breakers may indicate an overloaded circuit or a more serious electrical problem. Fourthly, electrical shocks. Any electrical shock, no matter how mild, should be investigated by a qualified electrician. Fifthly, water damage to electrical components. Water damage to electrical components can create a serious electrical hazard. Sixthly, outdated wiring. Outdated wiring may not be able to handle the demands of modern appliances and electronics. Seventhly, aluminum wiring. As mentioned earlier, aluminum wiring should be inspected by a qualified electrician. Eighthly, DIY electrical work. If you are not a qualified electrician, do not attempt to do electrical work yourself. Ninthly, home renovations. If you are planning a home renovation, consult with a qualified electrician to ensure that the electrical system is up to code. 10thly, pre-purchase inspections. Before purchasing a home, have the electrical system inspected by a qualified electrician. This can help you identify potential problems and avoid costly repairs. A homeowner should be aware of the amperage of the electrical system. The service amperage relates to the overall electrical capacity of a building, measured in amperes, often shortened to amps. It represents the maximum amount of electrical current that can safely flow through the service entrance conductors and into the building's electrical system. The service amperage is a critical factor in determining the building's ability to handle the electrical demands of its occupants and equipment. A building's service amperage is determined by several factors, including the size of the building, the number of occupants, the type of equipment used, and the local electrical codes. The service amperage must be sufficient to meet the electrical demands of the building without overloading the system or creating a safety hazard. Buildings with higher electrical demands, such as those with large appliances, HVAC systems, or commercial equipment, will typically require a higher service amperage. To determine the correct service amperage for a building, it is necessary to perform a load calculation. A load calculation is a detailed analysis of the building's electrical loads, taking into account the size and type of each load, as well as any applicable demand factors. The load calculation will determine the minimum service amperage required to safely and reliably power the building. There are several factors that can affect the service amperage of a building. These include, firstly, the size of the service entrance conductors. The service entrance conductors are the wires that bring electricity from the utility grid to the building's electrical panel. The size of these conductors determines the maximum amount of current that can flow into the building. Secondly, the size of the main breaker. The main breaker is a circuit breaker that protects the entire building's electrical system from overcurrent. The size of the main breaker limits the amount of current that can flow into the building. Thirdly, the capacity of the electrical panel. The electrical panel is the distribution point for electricity in the building. The capacity of the electrical panel determines the number of circuits that can be installed in a building. Fourthly, the type of equipment used in the building. The type of equipment used in the building can affect the service amperage required. For example, buildings with large appliances or HVAC systems will typically require a higher service amperage. The NEC National Electrical Code provides guidelines for determining the correct service amperage for a building. The NEC specifies the minimum size of service entrance conductors, the minimum capacity of the electrical panel, and other requirements. The NEC also provides guidance on load calculations and demand factors. It is important to comply with the NEC when determining the service amperage for a building. An inadequate service amperage can have several consequences. These include, firstly, overloaded circuits. Overloaded circuits occur when too much current flows through a circuit exceeding its capacity. This can cause wires to overheat and potentially start a fire. Secondly, trip circuit breakers. Tripped circuit breakers occur when a circuit breaker interrupts the flow of electricity due to an overcurrent or short circuit. Frequently tripped circuit breakers can be a sign of an inadequate service amperage. Thirdly, voltage drops. Voltage drops occur when the voltage in an electrical circuit decreases due to the resistance of the wires. Voltage drops can cause equipment to malfunction or operate inefficiently. Fourthly, equipment damage. An inadequate service amperage can damage electrical equipment, such as appliances, motors, and electronics. Fifthly, fire hazards. An inadequate service amperage can create a fire hazard due to overloaded circuits and overheated wires. If a building's service amperage is inadequate, it may be necessary to upgrade the electrical service. An electrical service upgrade involves replacing the service entrance conductors, the main breaker, and the electrical panel with larger components. An electrical service upgrade can be a complex and expensive project, so it is important to consult with a qualified electrician before proceeding. A homeowner should be aware of the main panel and its components. The main electrical panel, also known as the service panel or breaker box, is the central distribution point for electricity in a building. It receives power from the utility company and distributes it to various circuits throughout the building. The main panel is a critical component of the electrical system, and it is important to understand its components and functions. The main components of a typical electrical panel are firstly the enclosure. The enclosure is the metal cabinet that houses all of the other components of the electrical panel. The enclosure is typically mounted on a wall in a readily accessible location. Secondly, a main breaker. The main breaker is a large circuit breaker that controls the flow of electricity to the entire panel. It is used to shut off power to the entire building in case of an emergency. Thirdly, the branch circuit breakers. Branch circuit breakers are smaller circuit breakers that protect individual circuits throughout the building. Each circuit breaker is labeled to indicate the area or appliance that it serves. Fourthly, the bus bars. Bus bars are metal strips that distribute electricity from the main breaker to the branch circuit breakers. Fifthly, the neutral bus bar. The neutral bus bar is a metal strip that provides a return path for electricity from the circuits back to the utility company. Sixthly, the ground bus bar. The ground bus bar is a metal strip that provides a connection to ground for the electrical system. This helps to prevent electrical shocks in case of a fault. The function of the main electrical panel is to distribute electricity to various circuits throughout the building. The panel receives power from the utility company and distributes it to individual circuits through branch circuit breakers. Each circuit breaker protects a specific area or appliance from overcurrent. The main panel also provides a means of shutting off power to the entire building in case of an emergency. Electrical panels are typically rated for a specific amperage, which indicates the maximum amount of current that the panel can safely handle. The amperage rating of the panel should be sufficient to meet the electrical demands of the building. It is important to avoid overloading the panel, as this can create a fire hazard. It is important to regularly inspect the electrical panel to ensure that all components are in good working order. Look for signs of damage such as corrosion, rust, or loose connections. Also, check the circuit breakers to make sure they are properly labeled and that they are not tripping frequently. There are several safety precautions to take when working with electrical panels. These include firstly, always turn off the main breaker before working on the panel. This will de-energize the entire panel and prevent electrical shocks. Secondly, use insulated tools when working on the panel. This will help to protect you from electrical shocks. Thirdly, wear safety glasses to protect your eyes from sparks or debris. Fourthly, never work on a wet panel. Water is a good conductor of electricity, so working on a wet panel can be extremely dangerous. Fifthly, if you are not comfortable working on the panel, call a qualified electrician. It is always better to be safe than sorry when it comes to electricity. There are several common problems that can occur with electrical panels. These include firstly, trip circuit breakers. Trip circuit breakers occur when a circuit breaker interrupts the flow of electricity due to an overcurrent or short circuit. Secondly, loose connections. Loose connections can cause electrical problems such as flickering lights or power outages. Thirdly, corrosion. Corrosion can damage the components of the electrical panel and create a fire hazard. Fourthly, overloaded circuits. Overloaded circuits occur when too much current flows through a circuit exceeding its capacity. Fifthly, outdated panels. Outdated panels may not be able to handle the demands of modern appliances and electronics. There are several signs that an electrical panel needs to be replaced. These include firstly, frequent circuit breaker trips. If circuit breakers are tripping frequently, it may be a sign that the panel is overloaded or that there is a problem with the wiring. Secondly, flickering lights. Flickering lights can be a sign of loose connections or other electrical problems. Thirdly, burning smells. Burning smells coming from the panel can indicate overheating or a fire hazard. Fourthly, visible damage. Visible damage such as corrosion, rust, or cracks can indicate that the panel needs to be replaced. Fifthly, outdated panels. Outdated panels may not be able to handle the demands of modern appliances and electronics. Electrical panels should be installed by a qualified electrician. Electricians have the training and experience to safely install electrical panels and ensure that they are up to code. Attempting to install an electrical panel yourself can be dangerous and may violate building codes. Regular electrical inspections can help to identify potential problems before they become serious hazards. Inspections should be performed by a qualified electrician and should include a thorough examination of all electrical components. A complete safety inspection includes the electrical system. A thorough inspection includes the service panel and associated grounding. If there is a sub-panel, it should be inspected as well.